All right, so today we're talking about how do we divide when there is a decimal in the dividend. So if I start with an example problem, 485 divided by 3, okay? Remember that the very first number in my division problem is always going to be my dividend. And you may be thinking, Ms. Smith, there's not a decimal in that number right now. I know, we're just going to practice and recap how we divide in general. So let's set up this problem. So since 485 is my dividend, I'm going to put it inside the house where it belongs. 3 is going to go on the outside. And remember, when I divide, I ask myself the question, does McDonald's sell burgers? D stands for divide. So 4 can be divided by 3 just one time. M stands for multiply. 1 times 3 gives me 3. The S stands for subtract. 4 minus 3 gives me 1. And the B stands for bring down. So I'm going to bring down the 8. And then I start the whole process over again. So 3 goes into 18 a total of 6 times. 6 times 3 is exactly 18. When I subtract, I get 0. And then I bring down the 5. And again, 3 goes into 5 just one time. When I subtract, I get 2. And then normally our answer would be 161 with a remainder of 2. But after we learn about decimals in the dividend, remainders disappear. They do not exist anymore. We have a new way of dealing with that part that is left over. So let's look at an example problem here. Let's do 74 and 4/10 over 6. Now remember, when I've got, it's going to make the pterodactyl noise. Remember, when I've got a problem that looks like a fraction, the top number, the numerator, is always the dividend. So I'm going to put 74 and 4/10 inside the house where it belongs, 6 on the outside. And let's go ahead and divide. So 6 goes into 7 only one time. 1 times 6 gives me 6. When I subtract, I get 1, and I bring down the 4. 6 goes into 14 2 times. 2 times 6 gives me 12. When I subtract, I get 2. And then the next thing I have is the decimal. But it really wouldn't make sense to bring down the decimal because then I still just have that 2 floating down there by itself. So I like to say the decimals, they don't ever bring the party down. They only raise the roof. So they get brought up to the top as part of our quotient. So I'm going to bring that decimal up, and then that allows me to bring the next digit, 4, straight down. And then 6 goes into 24 a total of 4 times. 6 times 4 is 24. And when I subtract, I get 0. So I get a quotient of 12 and 4/10. Okay, let's look at another one. I'm going to come right here. Our next problem, let's do 482 divided by 5. Okay, so in this one, I'm going to start and I say, okay, well, 5 can't go into 4, but 5 can go into 48 a total of 9 times. 9 times 5 gives me 45. So when I subtract, 8 minus 5 gives me 3, and I bring down the 2. Then I have 5 goes into 32 a total of 6 times. 6 times 5 gives me 30. And when I subtract, I get 2 left over. And normally this is where we would write a remainder, but remainders do not exist anymore. Instead, what I want to think about is in every whole number, there's always an invisible decimal that lives at the end of that whole number. And what has to follow that decimal is the digit 0. So 482 and 0/10 is the same thing if I just wrote 482, except for when I include the decimal and the 0, I can bring the decimal up to the top. I can drop the 0 down, and it still allows me to keep dividing. So now 5 will go into 20 a total of 4 times. 5 times 4 gives me exactly 20. And I finally get a remainder right there of 0, which means I'm done multiplying. So done dividing. So 96 and 4/10 is our final quotient. Let's do one more. I'm going to pick, let's do 1,245 . 45 and 84 hundredths divided by 87. Ooh, yes, I like this one. Okay, so I'm going to start asking myself these first few questions. So first one is, can 87 go into 1? The answer is no, so I'm going to put a 0. 87 can't go into 12, but 87 can go into 124 one time. So I'm going to subtract 87. I can't do 4 minus 7, so I need to borrow. And this 2 becomes a 1. That 4 becomes a 14. So 14 minus 7 gives me 7. And then 11 minus 8 gives me 3. Now I bring down the 5. So now I have, how many times will 87 go into 375? And I don't know about y'all, but I don't know my 87s off the top of my head. So I kind of estimate here. And I say, well, okay, 87 is pretty close to 90. And 375 is pretty close to 380. So I know that 90 will go into 380 about 4 times, because 90 times 4 would give me 360. So I'm going to come try over here to the side. 87 times 4, right? Because that's my best guesstimate, my rough estimate, my best guess. So I'm going to check and see, does this get me close enough? 7 times 4 gives me 28. So write the 2, write the 8, carry the 2. Goodness gracious, this is why I don't make videos on a Friday afternoon. 8 times 4 gives me 32, plus 2 more, which would give me 34. And sure enough, 348 is about as close as I can get to 375 without going over. So that'll be 4 times. I'm going to subtract 348. Again, I can't do 5 minus 8, so I need to borrow. That 7 becomes a 6, and that 5 becomes a 15. 15 minus 8 gives me 7. 6 minus 4 gives me 2. The next thing would be to bring down the decimal, but decimals don't get brought down. They only raise the roof. But I can bring down the 8. Okay. So I know that 4 is going to be too much. 87, 4 times would be bigger than 278. So I'm going to try 87 times 3. See how close I get. So 7 times 3 would give me 21. So write the 1, carry the 2. 8 times 3 would give me 24, plus 2 more, which would give me 26. And that's pretty darn close. So when I subtract 8 minus 1, I get 7. 7 minus 6, I get 1, and bring down the 4. So 3 would be too much again. So let's try 87 times 2. 7 times 2 is 14. 8 times 2 is 16, plus 1 more gives me a perfect 174. So I get a final quotient of 14 and 32 hundredths.